Hi, everyone. My name's Tom McCooch. I am with MeshIQ. I have over 30 years of experience, the last 25 or so of which have been focused on distributed systems. So I really have a lot of passion around distributing or distributed systems. And For those who are into distributed systems, messaging is central. It's a central concept to any distributed system, just like shared data. So, from a messaging standpoint, I have spent a lot of time in and around the different open source projects, especially from the Apache Software Foundation. And I'm very pleased to be introducing JB Onofre, um, who is an 18-year plus veteran of the Apache Software Foundation, currently serves on their board of directors. So, JB, would you like to introduce yourself?
Yeah, thanks, Tom. Hi, everyone. So I'm JB. As Tom said, I'm director of the ISF this year, so the Apache Software Foundation for the second term. I'm PMC member and committer for more than 20 Apache projects on very different kind of domain, like big data with Apache Beam and contributor on Iceberg and mentor on Apache Polaris, but also all about, I would say, integration, including Apache Camel, Apache Karaf, up to messaging. So I'm PMC member for ActiveMQ. So yeah, that's what I'm doing. I'm passionate about open source, generally speaking. Passionate about all the system. I'm curious, so I like to dig into stuff like, hey, how things are going, and how we can improve this platform or this project. So try to spread the word about the ISF open source and how we people can use those projects for implementing the use cases.
Great. Well, that's what we're going to be talking about today. The two projects we're going to focus in on are Apache Kafka and Apache ActiveMQ, both of which you're very familiar. You've been doing a lot, kind of inside out, from the standpoint of ActiveMQ, and doing a lot outside in, integrating with Kafka, from the standpoint of Kafka. So um, we'll we'll kind of get right into it. There we go. All right, so let's introduce Apache Kafka, and we'll talk about ActiveMQ, and then we'll begin to compare and contrast across them.
Yeah. So on Kafka, first of all, you're right. I mean, I'm doing a lot of ActiveMQ more inside the project, so I'm directly contribute on ActiveMQ, mostly Classic, to be honest, but ActiveMQ Classic code base. So I'm pushing new features within the community, proposing new releases and stuff like that. My experience around Kafka is slightly different. I consider myself both as I would say, poor user of Kafka because I'm using Kafka for years now. But also, I had the chance to work on other projects, Apache projects, in terms of integrating Kafka in those projects. So, for instance, I work on the Apache Beam IO, where you can consume or produce record from Kafka. So
Yes.
basically, in Apache Beam, you consume uh, data set from Kafka, you send into a Beam pipeline. And I was one of the guys who was involved in this connector. So basically, how you consume or produce data records from Kafka in Beam or Camel, I work on it. So I'm not involved deeply in the code base of Kafka by itself in terms of project, but I know pretty well how Kafka is working and
Hmm.
how to integrate Kafka in other Apache projects. Um, for me, Kafka it's a great platform dealing with data streaming. Like I think sometimes we abuse about Kafka as a messaging platform. I think we have to be very careful about messaging, the meaning of messaging. I would consider more Kafka as data records, where you can achieve a very high throughput. So you can consume or produce a bunch of data, and this data is distributed across the Kafka cluster and distributed across partitions in one topic. So basically, you have a data records. Those data records are split into topics in Kafka. In each topic, you have partitions, and in partitions, you have one broker leading a partition, and eventually, you can have all the brokers replicating the partition. So it's what we name leaders and followers. And basically, in Kafka, you have one thing which is very important to check is ISR, so in state replica. That means, hey, your broker is in sync with the leader. It's a follower and is in sync with the leader. So that's basically what Kafka is data records organized in topics. Each topic may have one or multiple partitions, depending of the number of brokers in your cluster, in your Kafka cluster, and these partitions may be replicated on other brokers, depending on the replication factor you are using. This is great because it means that Kafka is using a, a kind of pooling mechanism. So instead of the broker is pushing data to the consumer pull the data from the Kafka cluster. So that it means that behind the hood, most of the logic in Kafka is on the client side. I mean,
Right.
really, the cluster is really dealing about replication, durable storage, um, data replication across brokers, stuff like that. But most of the logic is, and also another feature which is pretty interesting is the consumer groups. So by default, one consumer can only consume from one partition. If you have to have kind of concurrent consumers or individual consumers, then you have to deal with consumer groups. So I think Kafka is great in terms of horizontal scalability because it's pretty easy to add new brokers in your cluster, and then you say, hey, this broker provide this partition, and so you extend an existing topic, and it's really made and built for very high throughput. I think where Kafka is a little, I mean, it's not the first purpose, it's about delivery guarantee. I mean, you can achieve delivery guarantee, but it's different from a messaging system where the guaranteed deliverable is really the key of this kind of messaging system.
Right. So in with data records, you mentioned we have a we have a pull model, where the client pulls or streams, large amounts of data from the broker, and that's really how Kafka's designed. Um, yeah, with ActiveMQ and other message queuing technologies, it's more of a pull mechanism, or I'm sorry, a push mechanism, as you said before. And rather than a data record, we're focusing on a message. So do you want to compare? You want to talk about ActiveMQ now?
Yeah, that's right. So that's a fundamental difference between Kafka and ActiveMQ. So Kafka, remember, consumer are pulling message from brokers. In ActiveMQ, like any traditional messaging broker, we, I mean, usually we say, hey, I consume from ActiveMQ. That's actually not true. I mean, the broker push your message to your client. The broker push the message to um, the consumer. And the main difference is, in terms of model, is you can control exactly if your consumer get the message via the acknowledges, stuff like that. But the drawback of this, the trade-off of this approach is more you have consumers, potentially more you can impact the performance of your brokers because you have to deal with the broker has to deal, hey, I don't have to push to 10 consumers, but maybe thousands. And so the
Yep.
difference is to deal with. Imagine if you have a slow consumer. So for any reason, the consumer, I mean, it takes more time to process a message before sending back the acknowledge, then it can impact the performances of a broker. Whereas in Kafka, as is a pooling mechanism, whatever the number of consumers you have, it does not impact your broker basically. So that's a fundamental difference. But the push model provides also huge benefits, especially in terms of transaction. I mean, if you have to implement transaction, that's really where ActiveMQ is pretty good at. Like you can say, hey, I have a kind of exit transaction where basically I'm starting to I produce a message. I'm waiting for the acknowledge from the broker. Then I can consume another message. And then with a message that I got, I can send to another queue or topic, for instance. And all these actions can be gathered in one transaction. And if something goes wrong, then you can roll back all the previous messages you send extra. Because only when you send the acknowledge, only when the client sends the acknowledge to a broker, you actually consider that the message has been produced or consumed. So thanks to all these acknowledge mechanisms that exist in ActiveMQ, you can achieve pretty strong transaction. Another thing which is pretty interesting for ActiveMQ is the fact that ActiveMQ is based on standard. So you can use JMS, you can use IMQP, you can use MQTT, STOM, whatever. So it means that ActiveMQ is a good choice to integrate with legacy systems. Like imagine if you have to get messages from whole applications or to bridge with between ActiveMQ and another system, that's super easy. Another thing which is pretty interesting in ActiveMQ is due to JMS, we support both queuing and pub/sub mechanism in ActiveMQ. In ActiveMQ is what we name destinations. So when you create a destination, this destination can be a queue. So that's going to be a point-to-point kind of pattern. Or you can create a topic, which is a pure pub/sub broadcasting messaging. And both is implemented in the same broker. It's really depending on the destination you're going to use. So it means in your application, in your client, you can mix both queuing and topic, and it works just out of the box. You don't have to tune any, like consumer group or stuff like that. It just depends where you send basically the message. Is it a queue or a topic? Um, Sometimes I have some question from users asking, hey, can I store messages into ActiveMQ? And I would say yes, of course. I mean, the fact that the message is persistent or not persistent in a broker is actually a property of a message. So when you produce a message to ActiveMQ, you have a flag that say, hey, this message is a persistent message or is not a persistent message. And that's pretty interesting because it means in the same destination, so basically in the same queue topic, you can mix both persistent and non-persistent message. The main difference is when the acknowledge is sent back to the producer. So imagine I produce a message. This message is a persistent message. What ActiveMQ going to do is store into the message store. By default, it's KDB in ActiveMQ, but you can also use JDBC. So the broker receives the message. He sees, okay, this message is a persistent message. So I have to persist this message into my store. And only when the message is completely persisted into the store, the broker will send back to the producer the acknowledge. So we have a guarantee that when the producer receives the acknowledge, we are sure that the message is stored in the persistent store. And the same for the consumer. When the consumer starts to consume a message, so basically remember, it's the broker that pushes the message to the consumer.
Yes.
So the consumer gets the message, he sends back the acknowledge to the broker, And only that time, the broker will remove a message from the store, not before. Because if it doesn't receive the acknowledge, it means that this message has not been consumed completely and correctly. So thanks to that, with this acknowledge, we have really a huge focus on guaranteed delivery and transaction, both in JMS but also exit. Uh, this is purely JMS, but there's also some stuff specific to ActiveMQ. Is all about clustering and high availability. So by default, you have a single broker, but imagine for different reasons, you want to scale. You want to address a huge workload that doesn't fit in a single broker. So you want
Right.
to add new brokers. Then you're adding you are creating in ActiveMQ what we name a network broker. So basically, one broker can load balance messages. It does not balance the connections. It's really balance the messages, meaning that if I receive 1,000 of messages per second, maybe I'm gonna forward 500 to one broker, 500 to another one, or a different kind of split. So with a network broker, we can achieve a lot of workloads and throughput. And also, ActiveMQ support two kind of high availability. So HA on the network. So automatically, the client can use a failover mechanism that if the broker one is not enabled or is not accessible for any reason from a network standpoint, then the client can automatically switch to another broker in a list that is provided. And also, we also support HA on between brokers. So I can have one active brokers that receive all the messages. And for any reason, if this broker falls down, then I can have another broker which is inactive by default, becomes active and provide the same kind of messages and store the same messages because the store is shared. So thanks to that, we can have very kind of HA on between clusters, between brokers. Finally, another thing that it's pretty interesting in ActiveMQ is all about routing. So routing is a way that when I send a message, I can decide this message going to be pushed to this consumer or this consumer. Is what we name selectors. So one consumer can define, hey, I want to get only messages looking like this. And so automatically the broker will create a kind of SQL query, if you want. I mean, very abstract, where I can say, hey, these messages will be delivered only to these kind of consumers. We can also have composite destinations. So you send one message into a queue and you decide, hey, this queue is actually linked to another, to queue 1, 2, 3. And we can decide to duplicate the messages or just to route to one target queues. So that's the kind of thing we can do internally to ActiveMQ. And also another feature which is pretty interesting is ActiveMQ itself embed another project which is Apache Camel. So in the main configuration in ActiveMQ.xml, which is the main configuration for ActiveMQ, you can add camel routes, and camel routes allows you to have more rich, what we name EIPs, enterprise integration patterns. So with camel, you have a way richer um, way to filter your messages, to enrich your messages, to do some kind of what we name content-based routing, stuff like that. So that's
Right.
all this feature. So in a nutshell, basically ActiveMQ is great for transaction, generally speaking, very good latency due to the push model. But honestly, I think that if you have to send the same amount of data, Kafka is it's pretty better for very large data sets, whereas ActiveMQ is really for messaging per messaging, small messaging, and not, I mean, having messages pending in a queue for days is not a good use case for ActiveMQ. I mean, usually the messages stay in a queue or in a topic for, I would say, hours maximum, stuff like that.
Right. So from a Apache Kafka standpoint, um, you know, consumers really keep track of their message offset underneath the cover. So they're saying, I want to start reading from here. But in traditional messaging through ActiveMQ, it's the broker that's really keeping track of where you're at as far as from reading a set of messages, and that's why we get into some of the additional concepts such as high availability and some of those things because we have to keep track of that state in the broker. Additionally, we have a lot of additional power that comes with that, from a filtering standpoint and a message pattern standpoint, as you mentioned there as well. So thanks. Yeah. Um, let's get into some good practices, that, from a usage standpoint that we should keep in mind because both of these brokers have been out for some time, and they may have come out oriented, as Kafka did, mainly at event streaming, in the early days, and traditional, ActiveMQ was, oriented at traditional messaging, but the lines have blurred over time as one project has kind of learned from the other. So you want to talk to that a little bit?
Yeah. I think you're right. These projects are there for quite a long time now, and they also improve. I mean, like I remember the first version of Kafka. All about queuing was almost impossible at the beginning, and then they started. I mean, we inspired from each project is inspired by the other, I would say.
Right.
Like, for instance, I started to think about something that I named replicated KDB, which is a way to replicate messages across different KDB instances. That's very close to what Kafka is doing about partition replication, basically. So that's why I think that, if I compare Kafka now, Kafka has heavily improved its transactional guarantee over time. I mean, compared to the first version. And now with Kafka 4, it's even better. I mean, for instance, in Kafka 4.1, as far as I remember, they introduced new mechanism, new client protocol, stuff like that, which is super interesting. Uh, Even that, I would say that Kafka is super great when you have to do exactly once processing in streaming. Like, especially when you have both the source and sink using Kafka, it's pretty awesome to provide exactly once in that case. But if your source is Kafka and your sink is another, I would say, I don't know, ActiveMQ or RabbitMQ or whatever, then it's way more challenging because you have to convert the data record to a message and having all the errors and properties to transport all the logic you need. So that's way more challenging. But when the source and sink is Kafka, it just works fine. And that's pretty amazing. Something where Kafka is very strong, it's about, as you said, um, a consumer, a client, just use an offset. So the client can say, hey, I want to retry this record with this offset, and this offset is 2 weeks old. With Kafka, it's pretty easy because if you don't have eviction, so imagine you have an eviction per time. So you say, I'm going to do an eviction every month or 2 months, whatever. So it means that for a month, you have all the records stored on the storage. And so it means that a client can decide, hey, I want to consume and retry again this record from 2 weeks ago. In ActiveMQ, if you want to do that, you have two options. You can do redelivery policy. So you have a scheduler in ActiveMQ that maintains the message, or you send a new message basically. but it's way more challenging. With Kafka, it's pretty easy. The drawback of that is you consume a lot of storage. So you have to be careful about the storage you're going to use in terms of cost, in terms of the size of your storage. So and also something to remember is it's pretty easy to expand the storage in Kafka by adding new brokers in your cluster. So you just say, hey, I've had a new brokers. He joined the cluster. He is a follower for this partition. Great. But think about shrinking. How do you shrink your topic? That's not so easy because to decommission one broker in a cluster, you have basically to move all the records from the partitions managed by the broker. And so it's not easy at all. So uh, I would say
Rebalancing.
that, yeah, go ahead, Tom, sorry.
Rebalancing.
Exactly.
Yeah.
Rebalancing is it's not so easy. It could be pretty costly. So I don't think that we should compare Kafka and ActiveMQ in terms of competing projects. I would say that it's best of brand. Like depending on the use case, you can use ActiveMQ or you can use Kafka. The thing which is important is define which use case makes sense for Kafka or for ActiveMQ. I think for ActiveMQ, um, my first advice and a good practice is don't be afraid to tune ActiveMQ. I mean, don't assume the default configuration out of the box. You download Apache ActiveMQ from the Apache website, you extract and you run, and bang, it works. Yes, it works 90% of the time, but if your workload is super high, if you have some specific use cases, you have to tune a little your ActiveMQ settings. And I would say that the prefetch is I would say, uh, the first setup you have to consider because the prefetch limit is a way. Remember, ActiveMQ is a pushing model, so the broker gonna push the maximum of messages to a consumer. But if for any reason the consumer is not able to deal with this number of messages pushed by the broker, then it's gonna basically crash. It gonna be overloaded. So the prefetch limit is a way to say, hey, the maximum messages they're going to push to the consumer is this. And so by setting the prefetch limit, you are sure that your consumer is not the bottleneck, but also you leverage maximum of performances by increasing the prefetch. So sometimes by default, the prefetch, there are different use cases, but J speaking, the prefetch is 1024 number of messages per consumer. So if your consumer is able to deal with a bunch of messages, just increase the prefetch limit. That's going to work just fine. On the other hand, if your consumer is pretty slow for any reason, then reduce the prefetch limit. And that's something that the consumer can do on its own. So when he establishes the connection to the broker, the consumer defines, hey, this is my prefetch limit because I know I'm not able to deal more than that. So that's the kind of tuning you can do. Another advice is if you are using topics in ActiveMQ, you should consider to use virtual topics. So by default, just I remember, topics means pub/sub in ActiveMQ. So it means that one message to one topic going to be delivered to all subscribers on this topic. But it means also that one subscriber can only consume message per message on this topic. So maybe something which is very interesting is how we can have concurrent consumer on a topic. And so it's where the virtual topics is coming from. The virtual topics is a way to say, hey, on this topic for this subscriber, I'm gonna have multiple consumers. So that's virtual topics, and in terms of performance, is a huge boost compared to regular topics. And finally, if your throughput is super high, consider a network broker. I know that sometimes it's a little bit scary to set up a bunch of ActiveMQ brokers, but actually it works super fun. So by using network brokers, you can achieve to deal with a lot of messages in a network broker. So not a single broker, but a network brokers.
Right, right. So, um, so yeah, you can address use cases across the entire spectrum with both tools, and that's important to understand. But there are ways, to if your prefix limit, the common mistake, right, is having the prefix limit be like one, right? So, one message. So that really, impacts performance from the standpoint of a traditional messaging broker. So these are very important configuration concepts to understand. When kind of roaming off the reservation into some of those different use cases that maybe you would have traditionally, gone after a different message broker for.
Yeah, that's right. I mean, it's not, there are different tuning you can achieve on ActiveMQ. I agree with prefetch for consumers is probably one of the first tuning you should consider. But
Yes.
also, if you are using a bunch of persistent messages, there are some tuning to do on CarDB, for instance. Um, so I would say that the destination policies, the storage tuning, we also have a system limit in ActiveMQ. So basically, you have three system limits: temporary store and uh, um, I don't remember. Anyway, so basically you have three system limits. These system limits should be tuned depending of the capacity of each broker in terms of persistent message store, in terms of in-memory store,
Yep.
all about caching also. So yeah, this tuning is pretty important for ActiveMQ. Don't assume that all the box ActiveMQ is. I mean, but it's the same for Kafka, right? I mean,
Same
Kafka
thing.
is the same.
Right.
If you take a look at
You
the
have to think
brokers,
about
you have a bunch of tuning.
partitions.
Yeah,
Yeah. And
exactly.
consumers per partition and that type of thing, especially if moving beyond pub sub and trying to get into some queuing patterns. Yeah.
That's right.
So from an architecture perspective, they're both brokers. And a broker is just a simple concept. It's, hub and spoke, just thinking of that, uh, from a 30,000 foot level. But as you get closer, these are very different. So do you want to talk? We're going to enter the speed round now. I think we've got about 10 or so minutes to kind of
Sure.
go through these concepts, but we'll be able to compare and contrast, these brokers from a couple of different standpoint or visual viewpoints, if you will.
Yeah. So pretty quickly in terms of architecture, I would say that a broker in Kafka is a node in a cluster. So that's basically what uh, behind. I mean, in a nutshell, it's just a way to uh, construct a cluster by having multiple brokers, and producers send data to topics. These topics are partition, split it into partition on different brokers, so different nodes of a cluster, and then each consumer read from partitions. Um, well, one consumer, one partition by default. So you can see that the logic is the communication between the brokers in Kafka. That's basically a node communication. Hey, I'm leader on these. So that's why in the before Kafka 3, Zookeeper was used just to retain, hey, this is the node and this is who is the leader, who is the followers, and that's it. So in Kafka, the broker is really a storage entity, part of the storage in the Kafka cluster. In ActiveMQ is very different because in ActiveMQ the broker is a standalone messaging platform, I would say. So you can consume messages from one broker, from a client, but also from another broker. So it means that basically it's the difference between transport connectors and network connectors in ActiveMQ. The transport connectors are really between a client and a broker, and the network connector is broker to broker. So thanks to that, you basically sending and consuming messages in destinations. Uh, you don't need a cluster. A single ActiveMQ broker is enough to implement all the messaging platform. Then you can, anyway, you can expand to add active passive for HA. You can network brokers as we chatted before. But in a nutshell, just having one broker is enough to deal with messaging. In Kafka, you can have a cluster with a single broker, but in that case, you don't have any replication. You don't scale so much because you have all partitions in a single broker. So that's not the huge benefit of Kafka. I mean, for Kafka, I would recommend to have multiple brokers in your Kafka cluster.
Exactly. I like to think of it like driving in, America or Europe. With Apache ActiveMQ and traditional, message brokers, it's similar to America, right? You've got somebody or something that's conducting the traffic. With Apache Kafka, it's more like a circle,
That's right.
and
That's
to an
yeah.
American,
I
it
like
can
that.
look like a free for all,
Absolutely.
right? All right. So moving forward, messaging model. This is we touched on this a little bit before, but we'll put a
Yeah,
finer
yeah.
edge on it.
That's yeah. Just to I think it's something that we have to remember when we implement a use case and decide if this use case is a better fit for Kafka or for ActiveMQ. I would say that Kafka is really designed by default historically for PubSub. And for me, it's where Kafka is the best. I mean, really, PubSub in Kafka just rocks. Um, the queuing, you can tune your consumer groups to implement a kind of queuing, but this queuing is not as rich as the traditional queuing you may have in ActiveMQ. In ActiveMQ, this queuing is really about dealing with all the semantic of queuing, meaning that you can implement redirect policy where you decide, hey, I try to consume this message from this queue. It doesn't work for any reason. Then I can introduce a kind of redirect delay. So I will try again in 2 minutes, and I can create some kind of exponential backoff so it's going to be 2 minutes and then 4 minutes and then 8 minutes and then 16 extra. So you can see all the semantic. It's built out of the box in ActiveMQ. So you just need to configure it, but it works. In Kafka, if you want to implement the same logic, it's up to you to implement it. It's up to you in your application to mimic what the traditional queuing is. So I would say that generally speaking, PubSub is great on Kafka. Um, large workload is great in Kafka. Queuing, I think, is a little bit better in ActiveMQ, to be honest.
Great. Let's talk about performance.
That's a hot topic, I would say, because I mean that's the majority of the question we may have. Hey, Kafka is better than ActiveMQ in terms of performance, and I would say it depends. It depends a lot of the use cases. Depends a lot what you want to achieve. If you want to have very low latency, by low latency I mean that very low latency, probably ActiveMQ is better. And then, thanks to this latency and all the acknowledges we talked before, ActiveMQ is probably the best for transaction, generally speaking. So this push model, he has some issues, I would say, in terms of throughput and number of consumers. That's right, but it has a huge benefit for transaction. Think about financial transactions. I mean, for financial transaction, it's really key to have guarantee of delivery and transactional integrity. That's where ActiveMQ is the best. Honestly, it's where ActiveMQ is really made of. For Kafka, I would say that you have a bunch of data uh, to send in a short amount of time. Then the high throughput is probably better on Kafka, simply because you remember Kafka brokers are writing directly to the storage in a partition. To do that, you use sequential disk write. So it doesn't move the writing head to the beginning of the disk or whatever. It just happened on the disk, and thanks to that, it's super fast just to happen. I mean, it's always better to happen in the disk more than reading from the past. So with this happen mechanism, Kafka can achieve a high throughput, largely higher than ActiveMQ. Um, but ActiveMQ again is more about transaction and low latency. So that's again, it's almost impossible to say Kafka is more performant than ActiveMQ or the opposite. It depends a lot on the use cases you want to achieve.
Let's move into scalability while we're on the topic.
Yeah, another hot topic. That's true. I would say that um, scalability and fault tolerance is at core of Kafka. By default, data replication, partitioning is a great way to achieve scalability and fault tolerance. But it's what I said before. Don't do that with a single broker. It doesn't make sense.
Right.
But if you have I don't know, hundreds of brokers in your cluster, then you can achieve really data replication and scalability with partitioning. So uh, Kafka scalability is really at core. It's not the case for ActiveMQ. For ActiveMQ, if you want to achieve a scalability and fault tolerance, you have to set up that on top of your broker. A single broker is not scalable and is not fault tolerant. So you want scalability, you need to add network brokers. You want fault tolerance, you need to add active passive brokers. So I don't say that is not supported. I just say that it's up to you to set up your infra to implement HA and scalability in ActiveMQ. And you can mix both. You can have a network of brokers, and each broker in the network also have active passive. So then you have scalability and HA on ActiveMQ brokers.
Right. So it's not just a simple comparison between scale out and scale up. It's very much nuanced from that perspective. And thank you. I think that's a simple thing that a common misconception around traditional messaging brokers, that they're only
Okay.
scale up, and they're really not. You just have to look beyond the surface in how they come configured out of the box to see. I mean, I'm very excited about a replicated data store underneath of ActiveMQ. That is sort of the way a Kafka does it. So that'll be interesting.
Yeah, but that's not an easy one, to be honest. It's not so trivial to implement replicated KDB, but that's going to
Right.
be a nice and cool feature for sure.
So let's talk about admins. From an admin perspective, what's different between the two?
Yeah, that's for me. It's a very interesting topic when we talk about DevOps, admin, observe, all these topics, because usually I think that in such critical middleware and messaging platform like Kafka and ActiveMQ, you cannot say, "Hey, it's going to work." We have to be sure it's working fine. And to do that, we have to observe what's going on in a Kafka cluster or what's going on in an ActiveMQ broker. And by observe, I mean that um, do you have some kind of metrics that says, hey, it's not healthy? Or do you have some kind of metrics that indicate your application is not great? Stuff like that. So I would say that for both Kafka and ActiveMQ, being able to know exactly what's going on in your infra, it's more than key, because if you are notified when it's too late, it's going to be so painful to fix the issue. Imagine, I remember for one users, he got an issue with Kafka on the file system. And I can say that fixing an issue on the file system, bootstrapping the new brokers, doing a replication, replication of the messages, it was so painful. So basically, the downtime time was so high. So I would say that observe is key. For the operational standpoint, I would say that Prodi Kafka is harder to deal with compared to ActiveMQ. I mean, ActiveMQ is pretty simple, right? You just
Yeah,
take a Docker image provided by Apache and you just run and boom, it works.
right.
Kafka is not like this. Kafka, you have to set up your brokers, you have to join the same cluster, you have to create your partitions, you have to set up your replication factors, stuff like that. So I think that in terms of infra management, including partitioner, as we discussed together, partition rebalancing, stuff like that,
Yeah,
I mean, there are a lot of operational effort to do on Kafka. On ActiveMQ, for a single broker is super easy. Of course, more you have brokers, you set up network brokers, stuff like that. And it's not harder, but you have to deal with more infra. That's true. So I would say that in terms of operation, I would say ActiveMQ is probably easier to set up and to manage, generally speaking. About security, which is for me part of operation, like, hey, I have to plug on something. Uh, I would say all about authorization and authentication. In Kafka, as far as I remember, it requires additional configuration. It's not out of the box. It's up to you to add all the plugins to go into uh, setup with ACL, so access control list and stuff like that. In ActiveMQ, you have all the authorization and authentication by default. It's up to you to configure and to plug into, I don't know, Active Directory, IAM, or any identity providers and stuff like that. So I would say Observe is common for both Kafka and ActiveMQ. Operational, ActiveMQ is slightly easier compared to Kafka.
Totally agree. Let's end with developers. How is it different, for developers between these two tools?
Yeah, that's for me. Sometimes it's always very difficult because you have the developer standpoint, but also the infra manager standpoint. The administrator. So sometimes you have to align each other. Like, hey, I want to set up this. Yeah, but I have to tune like this. So um, I would say that ActiveMQ is really great if you have developers dealing with uh, traditional messaging and JMS especially. So you want to deal with AMQP, MQTT, JMS, all these pretty well established protocols. ActiveMQ is just perfect. I mean,
Yep.
just use this and that's it. You want to implement transaction? Easy. Go on JMS transaction or even XA if you want to do two-phase commits, stuff like that. Easy. A Kafka, if you use the pure Kafka client, go for it. I mean, if you produce a bunch of messages using Kafka client natively, that's great. If you want to do JMS or MQTT with Kafka, I know that there are adapters that exist, but honestly, it's never as powerful as native support in ActiveMQ. So I would say
Right.
that Kafka client, no worries. JMS on top of Kafka, I'm not a big fan of that. I mean, it's way better to use ActiveMQ for that or MQP or
Agreed.
MQTT. I think Kafka is really great for data data streaming and processing. All about IoT, JMS, all these kind of messages. ActiveMQ is way better. So that's again, you can mix both for sure. Just pick the one that makes sense for your use case.
All right. So with that, we've got some time for questions. Um, how are we doing? I thought the questions would come in through chat, but I don't see any. Are we getting questions behind the scenes, Jen?
Yeah, hey
I
Tom, we do have some
Hi.
questions coming through chat, and maybe perhaps
Great.
I can only see them. So again, thank
Okay.
you so much for this informative session. The first one comes in from Nikolai, and it came in around the halfway mark, around
Yes.
11:30. How do
Glad
you
we
see
got to them.
Kafka? Okay, great. How do you see Kafka being used for change data capture use cases?
So for CDC is a great question. CDC is really something that it's specific to data. So definitely is not something that ActiveMQ. I mean, ActiveMQ can get some CDC kind of messages, but Kafka is it's better. I think that Kafka on its own for CDC is not enough. So you can transport your CDC changes via Kafka, but the query engine that's going to use basically the CDC behind the hood to apply, it also matters. So depending if you are using Spark with Iceberg, so you can get through Kafka all the, so for instance, in Iceberg, we have a Kafka Connect platform. So you can get some CDC messages from Kafka, but most of the logic is actually implemented in the Kafka Connect Iceberg layer that try to consolidate, hey, this record has been updated with like this. How do you apply? So Kafka by itself is great for CDC implementation, but it's not enough in my opinion. It's also depending where you are pushing your data. So Iceberg is great due to the time travel, snapshot and stuff like that. But and it leverage Kafka. But Kafka alone, in my opinion, is not enough to achieve a great CDC. Even if you are using Debezium, for instance, Debezium is only using Kafka as or ActiveMQ as a gateway to transport the CDC events. Is not basically the CDC events management is not made by Kafka itself.
Right. Good point.
Great. Thanks so much, JB. Okay, the next question comes in from Kai. Beyond the general comparisons, could you provide more specific examples of throughput and latency differences that we might expect when moving from a traditional message queue like ActiveMQ to Kafka in a high volume enterprise setting?
Great question. I think it's also related to the model that we discussed today. Remember, Kafka is a consumer pooling model, whereas ActiveMQ is a pushing model. So thanks to the pushing model, the latency is way lower on ActiveMQ because the broker can deliver the message pretty fast to the target consumer. He doesn't have to wait the consumer to pull the message. Whereas in Kafka, the latency is slightly higher because in a pooling mechanism, the consumer has to get into the brokers, get the leader, the partition leader, and get the data. But on the other hand, the throughput is way better on the producer side when we have this mechanism because you can achieve way more um, throughput on Kafka. So I would say moving from traditional to Kafka or the other way around, it depends a lot about latency is probably better in ActiveMQ thanks to the pushing model, but the throughput is probably better on Kafka thanks to the pooling model.
Yes. And we've seen that, from our viewpoint of, observability, we've definitely seen that, as different use cases get moved or migrated, between
Yeah.
the two brokers. Latency is something that you have to, observe very closely, especially in the early days after you've migrated to ensure that, you know, the overall performance remains consistent.
Yeah.
Great. Thank you so much, JB and Tom. We have two more questions. The next one comes from Srini. Given the ideal use case discussed, what are the primary red flags or anti-patterns that would strongly indicate one platform, Kafka or ActiveMQ, is a definitively poor fit for a particular business requirement even if it seems appealing on the surface?
That's actually a very good question. It's pretty hard to list all the use cases that could seem as red flag, but I have some, general advices. For instance, think about the time of a message persists into a broker. If your message has to stay days in a broker, that's not a good idea to do that in ActiveMQ.
Agreed.
The pending time in ActiveMQ should be, let's say, hours maximum. But in
Yeah.
Kafka, it is. In Kafka, that's a great case. Your eviction could be based on size or be based on time. And then you can, your data records can stay in Kafka cluster for days. That's not a big deal. You just define the offset. So I would say that's the first question to ask is, okay, do I need to store my message for a long time in a broker? That's probably a red flag for ActiveMQ. Don't do that. On the other hand, let's say you want to be sure your message is completely consumed with guaranteed delivery, including a transaction. ActiveMQ is probably the best for that. So I would say that it's pretty hard to say this use case is for ActiveMQ or this use case is for Kafka, but by asking the right questions, like time of persistency, transaction delivery granted, that the kind of indicators that say, hey, is it better a use case for ActiveMQ or Kafka?
Okay, great.
Awesome.
Thanks, JB. And this one came in toward the end of your session from Craig. For organizations with existing complex enterprise architectures, what are the most common integration challenges or best practices when introducing either Kafka or ActiveMQ, particularly concerning their respective ecosystems and tool sets?
That's really, again, a very strong question and great question. By experience, I would say that it was on one question we discussed with Tom, but for me, it's really about observability. How you assure that both, I would say, your brokers, your cluster, but also the clients. So basically, the integration layers you are using. I don't know if you are using Apache Common, Apache NiFi, or Apache Hop or Talent, Absolver, whatever. But it's clear that the brokers and the ecosystem around, you need to know what's going on there in prod. Because if you don't know, when you will know, it's going to be too late. So my point is really anticipate, observe, and define the right metrics to know, hey, what's going on, and I'm healthy now.
That's
So that
exactly
would be
right.
my strong advice. Yeah,
Real time observability
agreed.
versus log monitoring. Yeah, you can't be looking backwards with messaging technologies in general. Everything that's happening is happening now, and you need instant or as close to instant visibility that you can get.
Perfect. Thank you so much to both of you. And that ends the questions. And Tom, back to you.
Oh, well, thank you very much for joining us, JB. As always, it's great to work with you. Um, we'll be seeing you soon, I'm sure. Yeah, thank you everyone for joining.
Thank you, guys. Cheers.
Take care.